Assalamu alaikum wa rahmatullah. Inshallah, today we will start our revision for assessment 2. First question, determine whether the following relations represent function or not. The relations are represented in Venn diagram. So the first set represents the domain, and the second set represents the codomain, and all of the chosen elements are the range. So how to decide if each relation is a function or not? Each element in X, each element in the domain must assign to only one value in the codomain. So A, it has only one arrow out of it. So it's okay, B one arrow, C one arrow. So the first relation is a function because each element is assigned to only one value in the codomain. Okay, second relation, the first element A is assigned to two values in the codomain. It has two arrows out of them. So this relation is not a function. Okay, let's continue. Third relation, we have the first element assigned to only one value. It has only one arrow out of it. But the second element, it doesn't have any arrows. It's not assigned to any value in the codomain. So this one also is not a function. Okay, relation letter D, we have the first element assigned to two values in the codomain. It has two arrows out of them. So this one also is not a function. So we have only one relation that is a function, which is letter A. Okay. Second question. We need to get the value of the function. Of course, this one is a piecewise function. It's a function and it's separated into more than one part. This is the first part, this is the second part, third part. So at first, if you need to get f of -2, at first you will search which part of the function includes -2. So the first thing we will search in the domain. So where is -2? Is it between -8 and 5, or between 5 and 15, or is it 15 or bigger? Of course, it's in the first part, it's between -8 and 5. So we will take this part to plug in our number in. So let's start by substituting -2 for x. It will be -4, -5, which is -9. Okay, the same with this one. We will search where is 0. It's between -8 and 5. So we will substitute in the first part of the function. So it will be 2 times 0 minus 5, which is equal to -5. Okay, third one, 5. We see 5 repeated 2 times, but it's in which part of the function? It's in the second part because we have an equal sign here, but we don't have them here. These are the numbers bigger than or equal to 5. So if you search for 5, you will find it in the second part. And the second part says the value of the function always will be 12. So here it will be the answer 12. 15, where's 15? We have 15 repeated 2 times, but in here we have all of the numbers bigger than 15 or equal to it. So we will take this part, which is -x, means negative, and remove x was 15, so it will be -15. Okay, here's f of 17. Do we have 17? Yeah, we have it. It's 17. 17 is bigger than 15, so we'll take the third part, also -x, so it will be -17. Okay, next. Use vertical line test to determine whether the following relation represent function or not. Let's start with the first one. Okay, it's a graph, so we need to use vertical line test so that we can decide if it was a function or not. If you found any line that intersects with the curve in more than one point, it won't be a function. It must intersect with the curve in only one point. So here it's intersect with the curve in one point, but we have to search in all of the domain of the function of the curve. So at this line, exactly at this line, this one, I have found a vertical line. Sorry for my drawing. A vertical line that intersects with the curve in more than one point. It intersects in 2 points. It's like this value for x is assigned to two values for y, two values in the codomain. So this one is not a function. Okay, let's move to the next one. This one, if you search for all values for x, you will find it that each vertical line will intersect with the curve only one time in only one point. So each value of x is assigned to only one value for y. So this one is a function. Okay, next one. This one also I cannot. So this one is a function. Let's continue. Okay, we have this curve and we need to determine if it was a function or not, but we see this. We have a vertical line that intersects with the curve two times, so this one is not a function. Next one, this one is a function because I cannot find any vertical lines that intersect with this line in 2 points or more, so it's only 1 point. So this one all the time is a function. So this one is function. Okay, this one obviously it's not a function because there's a vertical line intersects with this curve in 2 points, so this one is not a function. Next one. Okay, this one looks a function. Each vertical line intersects with the curve only one time, so it's a function. Function. This one also function. All the points is intersected only one time, so it's a function. This one is not a function, and lots of you confused about this one. We have a vertical line here, so if you draw a vertical line exactly at 5, you will find that this vertical line coincide on this line segment on infinite number of points. It's a line segment, it's infinite number of points, so it's not a function. This one's not a function. You have a vertical line already drawn for you, so it's not a function. Not a function. Okay, next one, we need to find the domain. If I asked you about the domain, it means can you find the values that you can replace x for? Uh, Actually, we can replace it with all numbers 90% of the time, but in some cases, we have some values for x that will give you a math error, or it cannot be allowed in your domain. It will give you something wrong. For example, this is a rational function. Rational function is it's a fraction. You cannot write 0 down. You cannot write 0 in your fraction. So x plus 5 cannot be equal to 0. So here are steps. Taking the denominator, equate it with 0 so that you know when it's equal to 0. Minus 5, so make it like this. Negative 5, negative 5. X is equal to negative 5. So you can use all of numbers except negative 5. So I can use all of real numbers except negative 5. This is your domain. So the domain is equal to r minus negative 5. And you can solve this one with your calculator. You will just write x plus 5 equal to 0 and then solve it. Shift calculate, solve it for any value for x. It will give you negative 5. Okay, and if you want to confirm this, it's not allowed to have negative 5 down. We have negative 5 plus 5. It's math error. You cannot use negative 5 for your x. But if you use any other number, it's okay. You can use any other number except negative 5. This one is the same. We have a rational function. So you will take the denominator, equate it with 0. You can use your calculator directly. So I will write 8 minus 2x equal to 0. And I will solve it for any value for x. It will be 4. So exactly at x equal to 4, the denominator, this one will be 0. So I can use all of numbers, all of real numbers except 4. Next. Okay, this one, it's a quadratic, so it's the same rational function. We will take the denominator, we will equate it with 0. We can use our calculator here. In this one, you can use mod 5(3) because it's a quadratic function. Mod 5(3). The first coefficient is coefficient for x squared, which is 1. Coefficient for x, you don't have x, so it's 0. And negative 16 is the absolute term. And your answers would be 4 and negative 4. So you can take any value for all real from all real numbers except 4 and negative 4. Okay, next one. It's the same. we will take x squared plus 5x minus 6 equated with 0. You can use your calculator and you can use factorization as you like. This is x positive negative 6 1. So x is equal to negative 6 or x equal to 1. In these values you will have 0 in the denominator, so we cannot allow that, so it will be all of real numbers except negative 6 and 1. Okay, let's move. This one is a radical function. Uh, Actually, you can use all of numbers except some selected values. Any value for this expression that will make it negative. You cannot have a negative under the square root. So I will tell him 2x plus 10. It cannot be negative, so it will be positive or 0. Okay, you can use your calculator by writing it as an equation, not as an inequality. So we will write 2x plus 10 and we will say let's equate it with 0. Then we will solve it for any value for x, so it will be negative 5. So x negative 5. uh, in this time you have to think about the coefficient of x. Is it positive or negative? If it was positive, keep the inequality the same in the same direction. If it was negative, just invert the direction for the inequality. In this time, you will write the domain as an interval form. It starts with negative 5 and goes all the way to infinity. So it will be negative 5 square bracket because it's an equal sign here. Could be equal to negative 5. Okay, this one is the same. You will take x squared minus 16 and you would say it's bigger than or equal to 0. Actually, this one you have to draw this straight line and you use your calculator. Use quadratic formula. Mod 5 is 3. Coefficient of x squared is 1. Coefficient of x is 0. Coefficient or absolute term is negative 16. It's 4 or negative 4. Okay, we will start with negative 4 and then 4 exactly as these 2 points. Okay, you have your function equal to 0, but I needed 0 or positive at first. Look to the coefficient of x squared. Is it positive or negative? It's positive, so make your parabola like a smile face. Draw it like a smile face. Passes through these 2 points. Do you see this part? This part is negative. We don't need negative. We don't need any negative value. So I can take all of real numbers except this part, which is negative. So I remove negative 4 and 4 from my domain. It's an open interval because I need only the numbers between them. But negative 4 and 4, it's equal to 0, so I have in my domain. Any number smaller than negative 4 or bigger than 4, I have in my domain because it's a positive value for y. Okay, it's a positive value for y. Next one. Okay, this one is the same. You will just take x squared plus x minus 6 more than or equal to 0. Use your calculator. Mod 5 is 3. The coefficient for x squared is 1. Coefficient for x is 1. Absolute term is negative 6. Equals, it's 2 or negative 3. Okay, we will draw this line. Negative 3, 2. Coefficient of x squared is positive, so it will be a smile face. This part is negative. We don't need negative value in our domain, so it will be our difference, negative 3 and 2. Remember, it's an open interval because negative 3 and 2 are included in our domain. Next. Okay, you need to find the domain and range for each relation. Okay, when I'm asking about the domain, you already know it. You will search for x values. X values here starts from negative 4, goes all the way up and down. Stop here. You don't have the x value is your function stops in the down part, but you haven't continued in the up part, in the top part, so you will continue with it. It's okay. You have some values for y up, so go and stop at 3, exactly at 3. We started with a point here. We have a point at negative 4 because it's shaded, so it will be negative 4 square brackets, and it stops at 3 round brackets. Okay, in this one we won't separate our domain at 2 because we have 2 up there. We don't include 2 down, but we have 2 up there. Okay, so it's okay. You will continue your domain. What about range? Range starts at -5, goes all the way up till 5. Exactly, it stops at 5. -5 is unshaded, so it will be round brackets. So the range here is -5 and 5. Open interval -5 and 5. Okay, let's continue this one. You will get the domain starts exactly at -3, goes all the way till 3. So we have -3 and 3. And what about the range starts at -2, goes all the way to 4. So it will be -2 and 4, and it's closed interval. Okay, next. This one, we need to get the domain first. The domain is starts from -5 and goes all of the way. It's not stops at 4 because they have an arrow. Goes all the way to infinity. So it's -5 and infinity. -5 will be square brackets. Infinity is round bracket. Okay, what about the range? Range starts from 4. Yes, range starts at 4. Don't confuse about this bracket. It's exactly a horizontal line, so it's not included. It's not going up to infinity or something, or going down to infinity. It's exactly at 4. So it starts at 4, goes all the way till -2. Sorry, -4, -2. So your range is -4, -2, and it's closed the interval. Let's continue. Okay, this one, careful about the arrows. It goes all of the way for a domain, goes all of the way in this direction to -infinity and this direction to infinity. So you have your domain, all real numbers, or you can write it as -infinity and infinity. Any one of them works for us. So let's get the range. The range starts directly exactly at -3, goes all the way up. We have an arrow, so it will go to infinity. So your range starts at -3, goes all the way to infinity. -3 is square bracket, infinity is round bracket. Let's continue. Okay, this one is tricky. It's separated into 3 parts. Let's start with the domain. Domain starts from -8, goes all of the way till -4, and then starts again from -4, goes all of the way till 4, and then starts again at 4 and goes all of the way. We have an arrow here. If you have a slant arrow like this, it means goes all of the way to infinity in x direction and in y direction. Okay, let's see how to write the domain. At first, we have this part. It's -4, -8 and -4. -8 is empty, it's blank, so it will be around bracket. -4 shaded, so it will be square brackets. What about the second part? It starts exactly at -2. I'll continue this one here. It's okay. -2. It's unshaded, so it's rounded bracket, and goes all of the way till 4. Do we have 4? Do we have 4? Yes, we have 4. So we have 4. And you started exactly at the same point. So it's 4, the interesting one. If you have them or you don't have it. If you don't have 4, you have to separate your domain because I don't have this point. But right now I have it shaded up there. So I have 4. So I don't have to split my domain. I'll go all the way to infinity. So it's -2 till infinity. We don't have any missing number here. We already have 4. We have a value for the function at 4. It's defined. So your domain goes all the way to infinity from this direction. Let's think about the range. Okay, careful. Your range starts exactly at -6. But do you see this part? This part goes all the way till infinity. It covers all of the points up. So it starts at -6. It goes all of the way till infinity. Of course, -6 is unshaded, so it will be around the bracket. Okay, let's continue. Uh, Careful about this one. This one's tricky. Do you see this arrow? This one means it goes all of the way to negative infinity in x direction and in y direction because it's a slant arrow. So your domain, we will say it starts at negative infinity till negative 6. And then it starts again from 0 till 5. And then it starts again from 8 till 10. So again, your domain is starts from negative infinity and stops at negative 6. Then it starts again from 0, stops at 5, and starts again from 8 and stops at 10. I hope that right now you understand when I will write it square brackets and when I will write it rounded brackets. Okay, let's search for our range. Do you see this arrow? Means goes all of the way down to negative infinity and it covers all of the point up to here. So I can say this, my range starts from negative infinity till 8. This 8 is it? This 8 is the square brackets. Okay, this one is the square brackets because it's included in our range. And then we have this one. We have this value for y. It's 10. So we'll add only one number. So we cannot write it like this. We will just put braces. So it's negative the half open interval negative infinity and 8 union the set 10. Okay, let's continue. This one, find the x-intercepts and y-intercepts from the graph and algebraically. Okay, at first we need to get it from the graph and algebraically. Yeah, this one's R. Okay. We need to get x intercepts and y intercepts. Obviously, from the graph, you can get very easy. These are x-intercepts. So the first one, 1, 2, 3, 4. I can estimate that it's 4 and 0, and the same in the opposite side, negative 4 and 0. Okay, what about y-intercepts from the graph? It's the same. We'll go up 2 units, so it's 2 and 0. Go down 2 units, so it's negative 2 and 0. What about algebraically? Okay, you notice this when you get x-intercepts, always y is equal to 0. So we will set y to 0 in your function. Sorry, in your expressions, this one. So at first, we will write x squared plus 4 times 0 power 2 minus 4 is equal to 16. And then you will solve it with your calculator. Okay, let's see it. We will write this expression, this equation, x squared plus 4 times 0 squared minus 4 is equal to 16. And we will solve it. He will tell me for which value for x. I will tell him my first guess is 4. So I'll tell him add 4. He will tell me no, your answer is not accurate, it's 4.47. 4.47. Okay, I'll tell him about my second guess. Make solve again. It's negative 4. He will tell me no, it's negative 4.47. So the second x-intercept is negative 4.47 and 0. Okay, this is the x-intercept. Let's do the same for y-intercept. If you want y-intercept, you will set x to 0 at x is equal to 0. Okay, you will start with your equation 0 squared plus 4y squared minus 4 is equal to 16. And when you write it with your calculator, you will replace y for, with x, okay? So it will be 0 squared, which is 0, okay? So it will be 4, and if you write it, it's okay. I will show it to you. 0 squared plus 4, replace y with x squared minus 4 is equal to 16. Okay, so Bismillah. And then we will solve it. He will tell me for which value for x. I will tell him my first guess is 2. He will tell me no, it's 2.23. So the first point is not 2 and 0, it's 2.23 and 0. What about the second point, the second guess? Okay, I'll tell him solve it again at -2. He will tell me no, it's -2.23 or 24. So it will be this one's 2.24 and this one's -2.24 and 0. Okay, we have learned how to get it from the graph and how to confirm it algebraically. Actually, from the graph, it's an estimation. You cannot get it with a 100% accuracy. So you have to confirm it algebraically so that you can find it with accurate numbers. So let's move. Second one is the same. You need to get x-intercepts, y-intercepts. So x-intercepts, y-intercept. This one, let's make it like this. From the graph and algebraically. Okay. At first, let's get from the graph. X-intercepts were seen here in 2 points. I will estimate it to be 2.3, for example. So it will be 2.3 and 0, -2.3 and 0. Okay. Let's confirm it algebraically. We have this equation. We will set y to be 0. So it will be 0 is equal to -x squared plus 6. All of these equations, you can use it by working out your algebra steps, but I prefer to do it with your calculator. You can do it as an quadratic equation, but right now I prefer to write this equation, write it down. So it will be 0 is equal to -x squared plus 6. And then I will solve it. He will tell me for which value for x. I'll tell him my first guess is 2.3. He will tell me no, it's 2.45. So the first guess is very close to the accurate number. It's 2.45 and 0. What about the second guess? I think it's the same with an inverse sign. So it's symmetrical about y-axis, so it will be the same, but let's check it. Solve it again for -2.3. By the way, if you write it any number that's closer to the second solution than the first solution, you will get the same answer. But let's keep it like this. It will be -2.45, -2.45 and 0. Okay, let's do the same with y-intercepts. At first, let's estimate y-intercept. It's here between 4 and 8, so it's 6. So it would be 0 and 6. Sorry. To get it, we will set x to be 0. At x is equal to 0, so it will be y is equal to -0 squared plus 6. Actually, this one, it's very easy to do it with your mind, so it will be y is equal to 0. So the point is true, it's 0 and 6. Okay, next. This one we need to determine if a function is even or odd. At first, we need to recap something. Do you remember at the graph when a function is even and when a function is odd? If you have your function symmetrical about y-axis, it will be even. If it was symmetrical about origin point, like this one, it will be odd. Okay, if it was neither one of them, it will be neither even nor odd. What about algebra? Okay, to solve it algebraically, you have to calculate f of negative x. Okay, you will get one of three cases. The first one, it will be the same as the first or the original function f of x, or it will be the same as it but with inverse sign, or neither one of them. This one is even, this one is odd, this one is neither even nor odd. Okay, let's solve our example. F of x. So x squared, f of x is equal to x squared minus 9. At first, let's calculate f of negative x. We have x here, so we will open a bracket. X squared minus 9. We plug in negative x inside the brackets. Let's do some algebra here. Negative x squared, it means negative x times negative x, so negative times negative positive, and x times x is x squared minus 9. It's the same as the original function, so it's the same as f of x. So f of negative x is equal to f of x, so this one is even. Okay, next one, we have f of x is equal to x cubed plus 5x. We will do the same, we will calculate f of negative x. We have a bracket here, so we'll make bracket cubed plus 5. Inside the brackets, we will replace x with negative x. Okay, we will do some algebra. Negative x cubed, it will be negative x cubed. Positive times negative is negative, 5 times x, 5x. Okay, you will ask yourself, is it the same as the original function? No, it's not the same. In this case, take negative as a common sign, okay? Take it every time, take a negative as a common sign, okay? When you take negative, negative times what equals negative x cubed, it's x cubed. And negative times what equals negative 5x, it's positive 5x. Ask yourself again, have you got the original function? Yes, I have him, x cubed plus 5x, but with negative sign. So it's negative f of x. So this one, f of negative x equals negative f of x. So it's odd function. Okay, if you took the negative sign as a common sign, if you make expression and you didn't find that you got the original function, it will be neither a even nor odd. Okay, let's do this one. We will get f of negative x. We will replace x with negative x. Okay, it will be 1 over x squared. It's your original function f of x. So this one is even. Okay, this one we need to identify point of continuity or discontinuity at 3. Remember, you have 3 numbers to calculate it here. If this one was your function and this point, I need to be sure the function is continuous at this point. At first, we will get the right limit, left limit, and we will calculate the value of the function at this point. If the three numbers are equal, then our function is continuous at this point. Let's start with the value of the function at x equal to 3. So we will say f of 3 is equal to 3 squared plus 2 times 3 minus 9. 9 minus 9 is 0, 2 times 3 is 6. So it's 6. Okay, how to get the right limit and left limit? We can use tables. So we will get limit f of x as x approaches to 3 from the left side. We will make this table. Okay, this is x, this is f of x. We'll start with the 2.5, 2.6, 2.7, 2.8, and 2.9. And then I get a value for x that's very close to 3, which is 2.99999, something like this. Okay, actually you can start from 2.7, You don't have to get all of this, but it's okay. You will do it with your calculator. So let's start doing it. We will make mood 7, which is stable. He will ask me to write the function. I will write x squared plus 2x minus 9. And then he will tell me what is the starting point? It's 2.5. What is the end point? I will say it's 2.9. Okay, 2.9. He will tell me what is the step. I'll make the step 0.1. And we have our table. The first one is 2.25. Okay, okay. Second one is 2.96. Third one is 3.69. Okay, fourth one 4.44, and fifth one is 5.21. So it will be 4.44, 5.21. Okay, I'm seeing this. We are getting close to 6, but we have to be sure about it. So what we'll do, we will just calculate it at this point exactly. So we will write our function, which is x squared plus 2x minus 9, and I'll tell him to calculate it at 2.99999. It's almost 6. It's 5.99992, something like this. It's almost 6, so it will be 6. We'll do the same for the limit of fx as x approaches to 3 from the right side. Okay, this time we can just make a shortcut for our steps. We will make our table starting from, okay, this is f of x and f of x. We can make the table start from 3.5 till 3, or it's from 3.1 to 3.5, but I will start from 3.1 till 3 point. Actually, I make this one 0, 0, 0, 0, 1, very close to 3, and this one 3.1, 3.2, 3.3, and enough. Okay, let's calculate it. At first, let's calculate at 3.0001. He'll tell me it's a 6. It's 6. Okay, we have to confirm the pattern here. We have to confirm the pattern. So what we will do right now, we'll make table mood 7. Write your function. It's x squared plus 2x minus 9. Okay, equal, the starting point is 3.1. Sorry, this is the other function. Starting point is 3.1, ending point 3.3, and the step is 0.1. Okay, it will be 6.81, 7.64, and 8.49. If you notice this, you are going close to 6. You are going close to 6. Okay, so the limit from the right side is 6. Because of the three numbers are equal, so your function is continuous at x equal to 3. Next one, continuous or discontinuous, we will do the same, but we will start with f of x, which is f of 4. Okay, if you plugged in 4, 8 minus 2 times 4, you will find a math error because the numerator is the same, but the down part is 0. Math error, so it's undefined. So your function is discontinuous at x is equal to 4. I didn't ask you for the type of discontinuity. So if I asked you about the type of discontinuity, you have to get the right limit and the left limit, okay, to determine which type of discontinuity do you have. Next one. This one is asking you if it was continuous or discontinuous. You have a piecewise function. In this case, I make it easy for you. When you get in the limit, you will just plug in your number. We will see it. At first, at x is equal to 2. Where is x is equal to 2? This one is a mistake. Just remove the sign. Here is x equal to 2. So we will say f of 2 equal to 12. We need to calculate the right limit and the left limit. Let's calculate the right limit. Limit f of x as x approaches to 2 from the right side. Right side, it means the number bigger than 2. Bigger than 2, it's from this one. X is bigger than 2, so we'll use the same number, which is x. Okay, so it's 2. It's not equal to the value of the function at the same point, so this function is discontinuous. Let's move. Okay, this one determined if the graph of the function is increasing or decreasing in the following interval. It's so easy. You will get a table. It starts from -10 and ends at -3. So x and f of x. -10, -9, -8, -7, -6, -5, -4, -3. Okay, use your calculator. Write the function 9 minus x squared. 9 minus x squared. Of course, after getting mode and table, okay, equals the starting point, it will be -10, end point will be -3, and the step here is 1. Okay, and you have your values for y for the function. It's -91, -72, that's -91, -72, -55. Okay, let's continue. -40, -27, -16, -40, -27, -16, -7, 0. Okay, we notice this, all of numbers are getting bigger, so the function is increasing on the previous interval. It's increasing. We will do the same here. We will do the same here. We'll make a table for our function. It starts at 1, ends at 8. Okay, we'll make a table. It's the same function, so I have it already here. I will start. You will tell me where do you want to start. I want to start at 1, ends at 8. Sorry, go back. Again, starts at 1, ends at 8, and your step is 1. Okay, it's 8, 5, 8, 5, 0, 8, 5, 0, -7, 8, 5, 0, -7. Let's continue. -16, -27, -40. -16, -27, -40, and the last value is -55. Okay, do you notice this? It's going smaller and smaller and smaller. So this one is getting smaller, so it's decreasing. Okay, let's continue. Determine if the graph function is increasing or decreasing on the following interval. We will do the same. We will do the same. We'll make a table. This is 0 and 2. You can make your steps to be 0.5, for example. So make it like this. You cannot insert 0 because it's not included in your domain, so it will be x, f of x. You can start from 0 0.5, 1, 1.5, and then 2. You can do it like this. So what you will do here, you will just write your equation x cubed minus 8 x squared plus 10. Okay, this one is x minus 10. It will tell me where do you want to start. I want to start at 0 0.5 and the end at 2. My step is 0 0.5, so it will be like this: 8.125, then 3. This one, 8.125, then 3. I'm sorry. Okay, my calculator went off, so I will do it again. I will go to mode 7, which is table. I write the equation, which is x cubed minus 8x squared plus 10. The first step is at 0 0.5 and sorry, the start is at 0 0.5, the end is at 2, the step is 0 0.5, it's 8.125, then 3, then negative 4.625, negative 4.625, okay, and then negative 14, negative 14. What do we notice here? It's getting smaller and smaller and smaller, so it's decreasing. We will do the same here. We will get a table. It's 6 to 8. It's suitable to take your steps as 0 0.5. So we will start at 6. We will end at 8. The step 0 0.5, it's suitable. So it's negative 62, negative 53, negative 39, negative 18, 10. It's getting bigger and bigger and bigger. So you will make your table, write all of this. Okay, we'll make it 6, 6.5, 7, 7.5, and 8. Okay, I'll erase this part. This is the values for x, and this is the values for y. 6.5, 7, 7.5, and 8. Okay, and this one, negative 62, negative 53, negative 39, negative 62, negative 53, negative 39, and negative 18, 10, negative 18, and 10. We see in this our function is getting increased, so it's increasing. Okay, let's continue. This one, find the average rate of a change. Okay, if you ask you about the average rate of change, it means you need to get the slope. It's y2 minus y1 over x2 minus x1. We will do it here. We have x2 and we have x1, so we'll start with minus minus. This is negative 2, this is 1. I'll get here f of negative 2, which is y2, and f of 1, which is y1. So I'll get my draft. F of negative 2, I'll plug here negative 2 in this equation. It will be negative 2 squared plus 2, which is 6. And f of 1, it will be 1 squared plus 2, which is 3. So it will be 6 minus 3 over negative 2 minus 1. It will be negative 1. Okay. Okay, we will do the same here. this is x1 and this is x2, so we will do the same. Minus minus 8, 5, f of 8, f of 5. It's y2 minus y1 over x2 minus x1. And we have to calculate f of 8 and f of 5. F of 8 is equal to 8 squared plus 2, which is 66. F of 5 is equal to 5 squared plus 2, which is 27. So it will be 66 minus 27 over 8 minus 5. It will be, okay, this is 33, 39. 39, yes. 9, 36, yeah, which is equal to 13. Okay, so this is the average rate of change. Let's continue. And we have finished, Alhamdulillah. Thank you.